Welcome to Summarize Science, where we break down the latest research. Today, we're talking about one of the weirdest types of planets ever discovered, superpuffs. These are low-mass planets with gigantic, low-density atmospheres, making their average density similar to that of cotton candy. The biggest mystery has always been their survival. Their huge, puffy atmospheres should be incredibly easy for a star's radiation to strip away. So how do they still exist? This new paper proposes that previous studies fundamentally misunderstood and overestimated this atmospheric loss. The researchers developed a much more detailed model that couples the planet's evolution with its atmospheric escape. They've identified a new process they call thermal energy-mediated photoevaporation, or TEMP for short. This is where it gets interesting. Instead of the star's energy just blowing gas away, in these low-gravity worlds, it's primarily converted into thermal energy. This heats the outflowing gas and fundamentally changes the rate of mass loss, making the planet more resilient than we thought. You can see the dramatic difference this makes right here. The black line shows the new model, which predicts a much larger radius over billions of years compared to previous models, shown in gray. This is a key piece of the puzzle in explaining these puffy planets. The model suggests that most of the atmospheric loss isn't a slow, continuous process. Instead, it happens in a rapid boil-off phase very early in the planet's life, within the first few million years. This early event removes a significant chunk of the atmosphere, but leaves enough behind for the planet to remain puffy for the rest of its life. To test their theory, the researchers applied it to real, observed superpuffs, like the famous Kepler 51 planets. The results were a fantastic match. The colored shaded areas, which represent their model's predictions, line up perfectly with the actual observational data points for these planets. Their work even suggests whether these planets have clear or hazy atmospheres. This provides strong validation that their new framework is on the right track. So, what's the perfect recipe for a superpuff? The study finds they need to have intermediate masses, around 5 to 10 times that of Earth. They also need to receive a low to moderate amount of radiation from their star, favoring sun-like stars over dimmer M dwarfs. So let's recap the major findings. Superpuffs are more durable than previously believed because of a newly understood mass loss process called TEMP. The bulk of their atmospheric loss happens in a quick boil-off phase early on, which stabilizes them for billions of years. This new framework finally provides a satisfying explanation for how these cotton candy worlds can exist. In the future, this model gives astronomers a powerful new tool to understand the thousands of planets being discovered. It helps piece together the grand story of how planetary systems form and evolve. Predictions from this model can now be tested with advanced telescopes like the JWST, pushing our knowledge even further. Thanks for watching Summarize Science. Don't forget to like and subscribe for more.